I would like to welcome to the stage my colleague, Cosmin Pintoiu, who is our big data architect, solutions architect. Actually, Cosmin is the one who has to repair our big data platform anytime I somehow manage to break it. And he's going to talk to you about advanced analytics. Thank you.
Thank you. Okay, so everybody's doing okay? I'm going to start from setting the right expectations from this talk today. I see it's called From Analytics to Advanced Analytics, but I'm not going to start the journey from ancient Greece to present times. Initially, this talk was called Advanced Analytics at Use. So on the second half, I'm going to cover a few use cases in real world, either POCs or live use cases that we've covered the last year. Okay. So some of the things that I'm about to say, or I thought I was going to say, were already covered during the previous presentation, so I'm trying not to duplicate that information. Okay? So, a few words about myself. I joined Bigstep in 2016, and I've been involved in a dozen of projects, some of them already in production that required some sort of upgrade or migration to newer versions, starting projects from scratch with proof of concepts, as Andrew already talked about them, and moving them into production. Previous to that, I've been in the financial industry, trying to implement and design and maintain mission-critical messaging pipelines. But then again, I don't think it's really relevant, so I'm going to skip. The agenda for today is a short classification and a focus on the type of questions different type of analytics are trying to answer. Then I'm going to talk a little bit about the team. There was a lot of interest there about different data teams, data analytics teams, and the different roles or emerging roles in this type of team. I'm going to mention a few words about the infrastructure to get you started with this type of projects. I'm not going to get in any details. And lastly, the use cases, which I thought, okay, pick one and deep dive, technical deep diving. But I don't know how many of you are Spark programmers, for example, here. Okay, thank you. So I thought I'd rather talk in a more loose way about this type of project. The kittens here have no connection whatsoever with the talk. I'm just here because they tend to be cute and make us have a smile on our face. Okay. So, what is big data and advanced analytics? And 2 weeks ago, I think, I came across a book called Slidology. I don't have a picture of it, but I do strongly recommend it. And the author there mentioned that in the chapter why presentations tend to be boring. And there are a lot of reasons why presentations are boring. It's not our focus, but some of the ideas happens to be in my presentation when I read it. And I said, oh, you know what, we should change that. So I'm not going to talk about the classical definitions or comparison between predictive analytics, advanced analytics, machine learning, data science, deep learning, and all that. I covered this with this slide. Our graphical designer said, but this is exactly the opposite of what I'm trying to do with your presentation. And I said, look, my point is here that you can easily Google this and have all these definitions in 2018 or prediction on their evolution for the next year, 2012, 20, and so on. So I took some snippets from Google search results. First page, because We know the second one is for hiding stuff, getting stuff in plain sight. So I thought let's go with my own way of classifying type analytics. So let's see what happened in the beginning with descriptive analytics, trying to answer what happened, and then moving forward to diagnostic analytics, trying to find out why it happened. And it's easy for me to resonate with this type of analytics, usually covered by the business intelligence tools, because I was, in the beginning of my career, I was looking at logs of data and trying to understand why the system failed. And it was a type of descriptive analytics at the time. It was manual work. I have to use a search engine. And then, if you move forward, we have systems that are trying to answer what could happen, what will happen, to do predictive analytics. Then we have prescriptive analytics, what should we do? And I think I have a typo somewhere. And lastly, cognitive analytics, because something could happen. And the last one is trying to get better insights, intelligent insights, trying to do natural language processing, trying to understand us, trying to identify objects in image, in real video feeds. And this type of analytics are covered, these disciplines are covered by advanced analytics. Now, I'm going to try to find, so I said the cognitive analytics are looking at the data and trying to get smarter or more intelligent insights and make you to make better decisions. And that requires data. So here I'm going to link with another discipline, which is big data. If we think at the beginning, we have the relational database systems. Okay, I'm not going to try to have a history lesson here, but we move to Hadoop systems, NoSQL systems, files and IoT in the present, having data structured, semi, or unstructured. And the connection with the volume of data is that if you imagine a machine learning system as a vehicle, then data is the fuel to which makes the vehicle run. So again, I know that at the beginning was the 3 V's related to big data. Not to mention them, but I do have an addition on the volume part because I consider that even though we're duplicating year by year the information that we've previously generated, it's still a lot of data that is not collected. And this type of, and the data that is not all analyzed. So there is a lot of potential. And moving forward, we have added another V, veracity, which looks at data accuracy and precision. And this brings me to the last point, which is data value. So this is the 5th V in this evolution of big data. Now, if I think of value, and it was an interesting talk that I looked at a while ago, it was there is a dense information in relational databases, and its value is very high. Well, when you look at unstructured and big data volumes of data, you think the density is low, so the information is sparse. So if you imagine even as a gigabyte of structured classical relational database data has a certain value, which might equivalent the say a terabyte of unstructured sparse data. So one of the most important part of analyzing this unstructured data is to increase its value. So you have to do a lot of cleaning, a lot of enrichment, a lot of cutting all the outliers, and have data prepared and increase this value for the data consumers that we see are basically data analysts and data scientists. I think I kind of covered this kind of an introduction. I do have a final slide of business intelligence versus big data. And looking again at small data sets with high information density using descriptive statistics and delivers a precise view of reality. While on the other hand, we have large data sets with low information density, uses inductive statistics, and delivers a model that approximates reality. Okay, so I think I'm going to move to the team. And I have a quick question. How many of you find themselves in one of these data jobs? Okay. And how many of you are here that are looking to create such a team or hire such a team? Okay. Again, there's been a lot of, we mentioned today a lot about this type of jobs. And there are some who emerges from this, between data architect and data scientist, recently found out that there's a data curator, which it's a lot of noise in their job description. I've been tasked by my HR to create a job description for a data scientist and data analyst. And I've created one and then adapted the other one just by modifying some stuff. And you're looking like you're looking for people with I don't know how many years in different programming languages, statistical, mathematical background, experience with Hadoop, with big data, with distributed storage, distributed processing, and these are very special and trained specialists. But you first day at work, then you're going to answer questions to how many clicks do you have today on our website, and you have to use them properly. And again, there is a lot of noise because some of them may have different jobs on a daily basis that you find in the other one's job description. As a simple definition, data architect or data engineer here we know is the guy who creates the pipelines, who moves the data, and who ensure the end-to-end flow of data, who eventually later dictate the pipelines and basically ensure the data is perform different initial ETL tasks on the data. And then you have the data scientists, which can query, interpret, build predictive maintenance, improve predictive models, and the last one is the business analyst. And this is what we see a team, and it might be a team that is third party, is not necessarily from your organization. Then the second part of the team is the one that's how we see it is on the customer side. So we have the C-suite here. Usually in advanced analytics projects, you have to give them from the beginning 100% buy-in. They have different tasks, and they can. Most of the projects tend to fail because they are not on board for the entire project. So here is where, as Andrew mentioned, you have to be very specific and clear about the proof of value, because they see the things in two dimensions. You see the cost of such an initiative and the return of its investment. So there is the C section. We move to the IT team. Again, a lot of interesting meetings where we have mixed teams from within the customer on our side. The IT team is always like, hey, that's interesting. Nice. Yeah, we're looking to, but he's thinking, oh, so you're looking at another VPN tunnel. Okay, so new tools, and I have to provide this data to your team to analyze it. Again, they act like facilitators or can be blockers of the initiative. So you have to get them on board, again, from day one. And lastly, the domain expert, which usually is on the client side, is the one that we call the translator. That needs a lot of experience in the job and understand the business needs, and also can translate them into things that the consultancy team have to look into the data. Again, these are kind of a general loose definition in terms. A few words about the infrastructure. The previous team, the one that you have the data scientists and the data architects, should use something like a notebook interface for data science and data preparation. Then we move to the business analyst that needs some sort of visual analytics. All these on top of a massive, of a parallel processing engine, on top of a storage that can accommodate this type of requests. So you have either Spark, MapReduce, Tez, or other parallel algorithms on top of file storage, columnar storage, and so on. Having the system capable of doing table metadata, and also all this circled with authentication and authorization. So this is a way of looking at an infrastructure from an abstract way. But behind each and every single block, there are so many tools, so many frameworks that they are looking to use. So the entire infrastructure has to be flexible in order to accommodate this need. If we look at the notebooks, probably your data scientists will be using Zeppelin or Jupyter, and Jupyter with different notebooks because they have experience in R. Some of them are very sophisticated background. They might be using Python or Scala with different frameworks. And what we see in practice to work better for them are different virtual environments, either using Conda or Python virtual environment. They can easily pack the necessary framework and packages in a single environment, and if they can actually test it and experiment with them for a short period of time and move to the next one if that's not what they were looking for. Same with the slice and dice tools that the business analysts might use. This type of infrastructure, we call it our data lab solution, and it's built with container images on top of Kubernetes, offers this kind of flexibility that I was talking about. Think of building your advanced analytics platform, starting with the Hadoop cluster from the bottom down, and build your data pipelines and configure and fine-tune your processing engine. And 2 or 3 years later, you're bringing your data science. What I want to say here is that you have to look at data as a minimum viable product. So start fast with the infrastructure, allow different tools to be used as ETL and pipeline, to create pipelines to bring your data, and offer the necessary flexibility for your data science team. Okay, so behind each and every little box here, you can find a link that offers an interface to either Jupyter, Zoom Data, Tableau, Click. You can bring stream sets, different tools that are easily to deploy via a Docker image. So I think this concludes my infrastructure. So up until now, it was a more or less simple introduction to advanced analytics. We talked a little bit about the team, and I hope you're going to have questions at the end of it. And a few words about infrastructure. Now let's move to the real-world use cases. And I'm going to start with retail. This is a Zoom Data dashboard. I presented here last year. I'm not going to any details here. You can see in real time different products and their speed of selling from today, because this chart is live. It's not a video, and I'm not doing any demo here. But what I want to talk about these use cases are the question behind them, as well as the challenges to implement them. Because I classify somehow analytics from a question perspective. Okay, so question is quite simple and it's not really advanced. Can I see my transactions in real time from how many stores? Let's go with 200. So the challenge here is obviously creating the necessary pipelines to move this type of data on the platform that can show in the real time. And also you can do slice and dice type of analytics here. As I mentioned, we're using Jupyter. This is another use case. And the question behind it was to determine what product should we introduce this month. And this is an open data set. You can take a look. It's Ecuador here. Again, we're doing exploration, cleaning, and modeling with Jupyter, and then we move to the results. So determining the new product's performance was the idea behind of stores that introduce a new product and keeps it for, let's say, 2 or 3 months and want to see how performant it is, because it might be more than one in the same class. So we introduce it in 2 or 3 stores, but we have to understand which one will fit best for the rest of the districts or zones. So one of the easy way here was to compare it with the average sales class, which is this right here. And we can easily identify the top performers. You also have to take into account the holidays, seasonality. We started with a single store and moved to the other ones. Here we have a chart that shows us the sales per week for a specific product and class. And this is the introduction of the new one. You can see it spike, and this is the curiosity behind it. What I want to ask next is, okay, I have this product which kind of we like it, and we want to introduce it. What is a more advanced question? Can you see what types of ingredients are making him the top seller? Because I want to understand for the next one to predict for a shorter period of time. So it's just a type of question. Anyone here from the insurance industry? Okay. So I think the question was, how many of you heard of telematics? Should I start from the beginning? It's a way, okay. It's a way of reducing the insurance premium by monitoring the driver's behavior. So what we have here is one of our colleagues monitored for a couple of months, and you can clearly see the location where he might have been, not necessarily a specific point, because the phone was with this function of significant change location, meaning that will consume less battery and will log a location point when its location has significantly changed. Let's see what are the challenges behind in order to determine a safe driver. So obviously we use the data while driving, accelerometer data while driving. We use the average time of the day, speed limit violation, distance traveled per day, distracted driver incidents, which we thought to be your action of opening and utilizing the phone while driving. Waze, it's asking you if you're a passenger or not. And the location type of roads, because each and every single road might have a certain risk associated with it. So we thought, let's mix all these and find a score, if I'm a safe driver or not. Now I want to ask you, how many of you will use such an application? Knowing this data is processed and we can decrease your premium by 30-40%. None. Yeah, that's what I thought. How about if all this data, it is processed, but it's processed on your phone and not sent to any cloud? Yeah, I might, I don't know. I'm a safe driver anyway. Okay, how about if all this data is processed on your phone, you only get the score, and this is not a black box. You are all aware of these metrics. Then you might be able to use it, right? Okay. I want this to be a little bit more interactive, so maybe if you have any ideas what we can add here, or how to make it less invasive. This is still a proof of concept. We're still collecting data. And because it's an idea that's hard to implement on a mobile device, Most of the insurers use this type of device with this type of telematics with a device installed in the car. So they log information directly. Even though they do have a lot of complaints saying, you're drifting with your car. No, I'm not. It was actually ice, and the car has troubles to start. And the application will log that as an aggressive driver, and its score is lower. Okay, so I'm close to the time. Predictive, and I'm going to mix this with anomaly detection in automotive in general. I'm not going to go to the end-to-end flow with this project. I'm going to focus on data encoding, storage, and decoding. When I started this project, I was surprised to see that there are more than 300 sensors that can be monitored on a truck like this, on a fleet of trucks. And there are components besides the engine that I didn't even know that exist. I'm an engineer. So the type of sensors, they store information. That store information are large, but the information is small. Because the most expensive thing in doing this type of fleet monitoring, is transmitting the data. So this happens over the air. So the data has to be very well encoded. Next, we storage in a system, we have to decode it. Imagine 200 sensors, almost around the clock, transmitting data, and then you have 10 years or less for a couple of trucks. That's a lot of data that can easily expand to terabytes of information. So here I would usually go into technical depths with Apache Spark in doing this type of decoding on a cluster. But I think I'm just going to stop the idea of analyzing and predicting this type of anomaly detection. The other problem was with the analyst, because the classical data scientists use on my laptop analytics, meaning that they know to use very well pandas, Python, and all the libraries associated, but they don't necessarily have experience with Spark MLD. So when you move from one PC to a cluster, to a distributed framework, a lot of complexity is added to that process. So we have to take step by step to use this type of machine learning library. Okay, and I think this is my last slide. Hope you enjoyed, and if you have any questions.